Well, hi, good morning. Thanks for joining me in my shop of frustration here. Today is November 25th. It's been a few days since I posted a video on this radio. Not because I haven't been in here. I've been in here every day, working away at the problem. The problem is the two highest bands, shortwave bands, the oscillator does not oscillate at all. And I've been hunting for the reason for this, and I have not found it. And I have done everything under the sun. I'm not going to go through the list of things I did, but anything you could imagine, I've done. And it has proven nothing. The one thing I have not done is I have not changed these critical capacitor parts back in here. I don't think they're the cause of a problem. Those are precision capacitors. My guess is their physical position in here is critical too. Everything is critical in here. I'd best not be fooling around too much. So I did make one observation, which is what I'm going to dwell on today. So what I did at one point was I decided to measure the negativity of the grid on the oscillator. If an oscillator is oscillating, its grid gets driven a little bit negative. And you can measure this. Of course, putting an instrument onto the grid of an oscillator tube is also a problem in itself. But nevertheless, I was able to discover something I think is of value for me to do one last, well, maybe last shot at this radio. And what I discovered is on the lowest band, that's a broadcast band, and the 49 meter band, the lowest shortwave band, the negativity of the oscillator grid was pretty good. Come up on this meter. We're going to have it on the meter here in a few minutes. You'll be able to see it. But when I flip, and pretty good, that's just a qualitative statement. I don't really know what it's supposed to be. It looked okay to me. Radio's working good. I guess that's what a good negative voltage measured with this meter would be. When I go to the 31 meter band, the second shortwave band, second of four. So lowest one working well. Next one, the voltage that the radio develops in the oscillator grid is very low. It's there, but it's low, meaning a weak oscillator. And then when I go to the next two higher bands, there's nothing. I cannot get it to oscillate no matter what I do. I threatened it. I threw my cat at it at one point. This one's weak. Now that's interesting, because maybe we can use this weak result here to fiddle around with the radio, and by seeing if it gets weaker or stronger, make some intelligent determination of something. As opposed to it's working or not. It's always not. There's not much you can do if it's just not working. This is I've never encountered this kind of problem in a radio before. At least I've never been aware of this kind of problem. Maybe I let it go by in the earlier years without even realizing what was happening. So, and I've been doing a little bit of reading on this. This is a big challenge in a lot of radios. The oscillators misbehave for reasons no one seems to be able to fathom. So where am I at now? Okay, so I do have a little bit of hope. I have this partial voltage to observe for testing, and look at all these tubes here. Now I've got 3 spare tubes. I've already cycled them through the radio once. You didn't see it on video. I've also tube tested all of them except for one of these. One in particular is pretty good. This one. This is a joint Army-Navy tube, so this is a little bit better built, and this one's actually the strongest one. But I just discovered I also have this guy, a 1620, which is exactly the same tube with just a different number on it. So I haven't tested this one yet. And then there's 2 in the radio. They both test similar strengths. Not all that good. They don't test all that good. They're just into the good a little bit. So what I'm thinking is I'm going to cycle all these tubes, all 5 of them, through the oscillator position. And I'm going to watch what happens on the meter to see the level of negativity in the grid. And what I'm hoping is I will see a variation in that related to the strength of the tube. Is this ultimately going to make the radio work on the higher bands? I can't see how, because I gave it every chance already. I put the best tube in there already. Unless this 1620 is some kind of super tube. I don't think it is, because this one actually came out really good on the tube tester. So you'd almost think it can't be a weak tube. Yeah, okay, so I've spent days like this. I've been running in here in the afternoon. I've been staring at the schematic. This is really driving me nuts, frankly, this kind of thing. You know, it's a love-hate relationship. You know, I like it because it makes me think. I think of curious things and come in and have some fun. I don't like it because I'm not getting anywhere. That's really, really upsetting. Okay, it's not too hard to get this happening right away. I think maybe what I'm going to do is how should I do this? I need some objective measurement of each of these tubes. Maybe running them all through the tube tester and making some notes. That's what I'm going to do. First I'm going to test all 5 tubes, make some notes, and understand what we've got there for tubes before I start this with the radio. Just a little more to the story here as I'm getting ready to do this tube testing. During the course of me working on this radio, I had a tube tester break down in the middle of testing tubes, which was extremely confusing and disappointing. And I also had my little audio amplifier break down, and and it's gone. You can see it's not on my bench anymore. One of the problems I face here in making these videos, if I don't post everything, after a couple of days, I just lose complete track of what I've put out in public that you might have seen and what I stated that might be on a video you're not going to see. I just don't know. So I can repeat things, or can assume you've heard me say something or know something that that you don't. For instance, what happened to the audio? So that's what this is. This is an audio amplifier. This is a power transformer I'm using as an audio transformer because I can't find a real one. And it's hooked up to the audio coming out of the radio here, and it's feeding straight into my audio system here, which has been up all this time. Hopefully you have not been hearing some kind of hum or buzz other than that. So now the radio, instead of feeding out of a speaker and through microphones for you to hear it, is actually going straight into my my audio, my video system here I'm using to make audios. Jim, what's the matter with you? Too much coffee too rapidly this morning. So, great. Let me get everything all... Yeah, I got to do the tube testing thing here. That's right. That's what I'm doing. I'm testing tubes. Okay, so this is the original oscillator tube. WY. Comes up to 80, but it's falling a bit. 80%. Falling down to 75. That's the first tube. Okay, this is the tube I numbered as number 1. It's the tube that came in the radio that was operating the automatic frequency control, which we haven't even gotten near yet. Let's test it. 75 dropping back to 70. Okay. Okay, so this is tube number 2. So I've numbered all the tubes with a little tag to keep them straight. Tube number 2 in here. Tube number 2 is out of my collection. I've already done all these tests. These have all been tested already, but we're going again. Here we go, WY. Like 82, not really going down at all. 82%. Now I'm doing this testing in what is essentially an emissions tester, a high quality emissions tester. I'm not using a dynamic tester to do this. You know what it says? It says dynamic. Oh my gosh, better eat my words. I wonder what that word means. I don't think this thing is measuring the mutual or transconductance. Dynamic? Okay, let's test this guy. This is tube number 3. This is the Jan version of the tube. This is the one I think is probably the best. So that's coming up on here at about 92, 93%. The 100% is really good. Okay, that's good. So when I was looking for different replacement types or substitutes for this particular type of tube, I discovered there really aren't any. Although the same tube carries a different designation. It can be a 6J7 or it can be a 1620. This is labeled 1620. I haven't tested this tube before. It may not work at all. Let's see what happens here. No shorts in it. I mean, what? Oh, it's just like the Jan ones, right up at the same number, 90, 93. Good. So I have two pretty good tubes that measure exactly the same. Great. 93. Okay, we're ready for the first test of all this using the original tubes in the original positions, tube 0 and tube 1. So I have the heaters warmed up. I'm going to be turning up the B+ now, and we'll get the radio operating. Remember, you're hearing it directly into the sound system. It's going to be very shrill. It's the tonal quality is shot because I'm using this great big transformer here. I'm pretty sure it's the reason. But we just need to hear sound. We don't need to hear beautiful sound. Okay, so I'm going to crank the B+ up, and let me just move this on to the correct band we want to start with. Is the broadcast band, because it's the noisiest. Here we go. Come on, baby. Do your thing. Okay, so I've set it for 25 milliamps, the same drain I usually set it to. Maybe the volume's down here. Wow, that's really not a very good response at all. Everything's turned up. Let's tune the radio a bit here. Okay, so you can tell there's a local oscillator in the radio because I'm tuning through stuff. Sound quality is just because of the way I'm pumping the sound into the video. So, but it's definitely working. Now, what's going on the meter here? Whoa, we're way over. Didn't even notice. Way over. There we are. So the scale I'm on is the 15 volt scale and negative. So we're up about 7 volts right now. Let me tune this. See if that doesn't. So that shouldn't vary. This isn't an EDC voltage. It's really all about this meter reading here. So let's zoom in on it. Pretty horrible lighting happening here. So I'm going, tuning down from the top of the band. I'm tuning downwards. So it essentially represents the strength of a local oscillator. We've never done this kind of study before. Okay, we're almost at the other end. End of the road. Okay, let me crank it up just a wee bit. So there we go. So that we can declare this to be the proper voltage, although I don't know that it is. But that's fairly impressive. What is it again? It's 15. It's about 10, 11 volts built up. Now, where's this voltage coming from? This is coming on the grid. It's being developed in the oscillator grid. And it's a result of some grid current when the grid is driven positive relative to the cathode, because the initial oscillatory signal, grid has no bias when you first start it. So the first positive wave kind of goes through, the grid becomes very positive, and it acts like a plate, draws some electrons. Collects in the electrons, now the signal flips to the negative side, grid stops collecting electrons, but it has them. It has this extra charge now. Grid goes a little bit more negative during that half cycle. Next half cycle comes positive, can't go quite as positive relative to the cathode because the grid's now been made a touch more negative. Nevertheless, the grid goes positive, collects more electrons, gets driven more negative, and this process keeps happening every cycle until finally the grid is so negative that the signal doesn't cause a positive moment in the grid. Well, it probably always does a tiny little positive moment just to top up the charge. Now, why doesn't that just keep going more and more negative here? Because at the same time there's a resistor on the grid leaking off the charge. So it's the balance between the grid absorbing or obtaining electrons inside the tube and shedding electrons by having them leak out this resistor to the chassis. And that ultimately resolves a voltage. This is a typical way of biasing a lot of tubes. A lot of tubes are, it's referred to as self-biasing. Okay, so there we are. So this is good example of a band apparently working properly. So now we're going to go. So I should start changing. Oh wow, I'm going to change the tubes over and over and over through every band? No, I'm going to go through all the bands and record this reading, and then change tube and do it again, change tube, do it again, get that whole thing done, and then we'll be looking at a chart. I don't think I'm going to have you. I think I'm going to video myself doing this because it's rather repetitive and boring. But that's the basic. Well, I can do the first one. Jim, do the first one. Okay, so we just go to the next band. I have to make some notes here. I'm not quite ready for this. Here, I can do them right here. So on the broadcast band, the actual measurement is 10.8 volts. Okay, we go to the 49 meter band. Now you might say, well, yeah, no, you wouldn't say that. Sorry, the thought just raced through my head, and before it came out my mouth, I realized that it shouldn't come out my mouth, so it didn't. Instead, all this garbage dribble just came out. Okay, 13 volts, so it's actually higher here. Let me just tune the radio a bit, just see what that does anything. So we're going up in frequency, driving the oscillator upwards. Of course, the oscillator is not changing much. On the broadcast band, it is. But on the rest of these bands, the oscillator is varying only a small percentage from what frequency it's on. So we don't see any change. Next band. Now, this is where it gets interesting. It's a huge drop-off down to a lower value. And I suspect whatever is causing the two highest bands to not oscillate is the same thing that's causing this low voltage here. It should be up here where the other ones are, shouldn't it? So I'm going to tune the radio now, and this may really give us something here. If I'm going down in frequency, and nothing is changing. I'm going up, up. So what I would hope would happen as I go up in frequency, it gets harder for this radio to generate this voltage. But no, I don't see any change. Not even a minuscule change. We're going down in frequency. That would cause the voltage to go up, I would hope. No, no change. Very, very stable. That's very, very stable. So the actual voltage here is 3.5. That's quite a bit different. And now, for sure, if we go to the next band, it just drops to 0. That's a 0. And the next band is also a 0, and that's it. That's what we always get. Zeros. So this is the band of interest. As I change the tubes, it's this reading that I think will be varying, and that will show me that it's the strength of the tube that's responsible for the strength of this. That's what I'm doing. That's what I'm trying to do. Yeah, I'm trying. You know, we're in a position to do another fundamental test, and that is the variation of the B plus and its effect on the oscillator. You have to imagine putting more B plus on the oscillator plate is going to cause it to oscillate with more current, or oscillate more strongly, or generate a different reading here. So let's try that before I get too far into this and miss this opportunity. So right now the B plus is somewhere just over 100 volts, I think. I'm going to raise it here. And I'm going to lower it because that's easier to do. Okay, so watching, down. Oh yeah, just dropped right off. Let's put it back where it was. Okay, that's roughly where it was. Now, if I just take this up, it's coming up, isn't it? I have to watch the current on the power supply. That's as high as I can go. Something funny is happening right in here. The current draw from the radio is varying by almost 100%. It's almost doubling. I'm varying the B plus voltage back and forth, probably 10 volts at 200, and the current is just going wild. Well, and there's a limit on my power supply up there, so let me just show you what was happening there if I can. Okay, this is a little awkward here. So you're watching this current meter, and you're watching my hand turn this control. So it's all the way, to get to here, 25 milliamps, it's all the way from here. I'll go up a little bit higher. Now, watch the variation. So it's almost as if something's running away up here, or something is starting up that doesn't run otherwise, or something, I don't know. And that's when we get the matching variations. Oh, sorry about that, I'm not watching what I'm doing here. Did I get that on camera? I think I did. Whoosh. I don't want to go past the red line here, because I assume the red line means danger. Danger. So, what is doing the strange thing on the power supply? I don't know. Could just be, what, you're raising all these tube currents together? Maybe they're all going up together, and maybe that's making it look like something very non-linear is occurring. Well, I guess something non-linear is occurring. But it's not helping the oscillator at all so far, and I've done this B plus test on the two bands that don't work. It doesn't do anything. So now I want to make sure the B plus is set in my standard place. 25 milliamps of flow, and just for interest's sake, you know what, I'm going to leave it on this band. We're going to go through the tubes, because this is the only band that has something interesting here. And I've recorded this number, 3.5 volts. Now it's not 3.5 because I fiddled with everything. Now it's 4.5 volts. Let me just change it here. That's probably the variation of the B plus setting. 4.5 volts. Sorry about that. Bang there. Now we pop out the tube and pop in. So I'm gonna leave this tube, the frequency compensation tube, automatic frequency control tube. I'm gonna leave it there, and we're gonna change the other one. Now, to do this properly, I really should shut the radio off, so I can put this voltage on the standby. That way, I haven't moved any of the adjustments. Now, just kill the heater current briefly. Probably don't need to do that. Get this out. So, you know, I have been operating this radio on a power supply. Maybe that's really the root of the problem with the oscillator in here. And if I were to operate the radio with its internal power supply, maybe everything would work. I don't know. Can't do it because I don't have the speaker. But at the end of this video, depending upon what happens with this test, and I can guess what's going to happen, I will stop work on this radio. I set it aside. I will seek the speaker for the radio, and we'll carry on somewhere down the road with it, with its own speaker plugged in and its own power supply, providing the B plus, because that's the only way to eliminate these possibilities. Now, while I'm talking, have I done the right thing? Did I just put the wrong? I have tube number 2 in. That's right. So tube number 2, and we just flip on the heaters here. Give it a moment. Let me flip on the B plus. And it should return to exactly where it was. So we should be able to compare the results here. Okay, B plus going on. It's interesting how slow that's building. I kind of think a oscillator would kind of snap into action, and with just a few cycles it would be full tilt. That took quite a while. Now, the voltage we're getting there Yeah, it could be the radio was still just warming up generally. Looks like it's going to settle in at 4 volts. And we have 25 milliamps on the current. Looks like it's going to crawl up above 4. If they give it long enough, it's going to reach the same voltage as the last one, 4.5. Looks like it's stuck at 4.2. So we're going to put 4.2 here, volts. And we're going to switch. I'm going to switch now to a tube which is more. Okay. This is the one with a bit of a higher reading. That would be tube number 3, 93%. This is the Jan. This is the Beauty. There's no way somebody can argue that this is a weak tube, I don't think. Okay, I'm going to give it a moment to warm up. This time I didn't break the heater current, so all the tubes stayed warm except for the one I just put in, of course. Okay, let's hit it with the B+. Coming right up into the same zone, slightly higher. So what I'm hoping for is I put in a tube that's dramatically stronger. I don't have one that's dramatically stronger, and I would get a dramatically different change here. What I'm doing is I'm putting in a tube now that's rated at 93% in that tube tester over one that was at 82%. At 82% we get 4.2 volts. At 93% we get 4.8. It's just not dramatic enough for me to get too excited over. Now we're going to check the 2 higher bands because I'm in a position to do it. 0. That's a 0. That's a 0. You'll have to trust me that that's where the 0 is on that meter right now. Back up. Well, this experiment has not worked out. The other tubes are going to be the same. The thing I've been reading up on this stuff too, and I understand now that this is one of the classic killers for a radio repairman. Is an oscillator that won't oscillate no matter what you do. And what I'm doing today is trying different tubes is one of the standard techniques for trying to get around this apparently insurmountable problem. You just keep trying tubes until one of them oscillates. Not quite my style, but now the only tubes I've got now is just got one more tube, and it's really ranked pretty much the same. It's the one that's in there, so we'll give it a try. I think I'm definitely barking up the wrong tree here. Okay, I'll let it warm up for a moment. So I did measure all the resistances of all the coils. I tried crazy injections of signals. I tried weird ways to detect the resonant point of the coils. None of these things really worked out all that well. Certainly these coils are not. There's not an open coil in this system at all, or anything like that. Open capacitor, it just doesn't exist. And the resistors are all within tolerance. How do you like that? That it basically, what I believe is the circuit is perfectly fine, but just doesn't work. Okay, B plus added in here. There we go. Current in the radio quickly rose to 75 milliamps, very quickly. And we are again. Same spot. So I think what this is really telling me is, yeah, the tube's going to have some effect, but the reason this is not way up here is not because of the tube. Something else is dragging down the oscillator circuit. something else is dragging. Let me just check the other two bands. They're gone. They're not even there. Not even getting off the ground. So the oscillator circuit will have some kind of a Q factor, some desirable Q factor, which can be affected by resistances and stuff like that. Is there some resistance in the circuit that shouldn't be there? Can't imagine it. Like a switch contact, like a cold solder joint. Because it's two bands. If it were one band, you could really hunt down one thing that's causing this. There's two bands involved. There's actually three bands sharing the same circuitry. One of them is weak, the one we've been working on. The other two don't work, but they share the same circuitry, just a different size coil. And something that's a little interesting about this radio, which maybe is a hint too. So this is the coil for the highest band, for the 15 megacycle band. If you look really closely, if I hold the camera still enough, you can see there's not just the three turns of big wire, there's a thin wire in between. This is a transformer. These are not. These are coils, just coils. This one looks like it's a transformer because you can see the two. Coil, transformer. What are they doing here? The plate current from the oscillator tube runs through the fine wires in there. This is I believe what they've done here is they've added an additional level of feedback to help the oscillator oscillate at the highest band. They didn't bother doing this on these other coils because apparently it'll oscillate. Well, so this is suggesting to me, since this is an added expense, it had to be done to compensate for the radio's inability to oscillate without it. This is a technique the engineers here will probably proudly developed, and it's only used on the highest band. So what I'm interpreting from this is it takes a lot to make this thing oscillate. And maybe we shouldn't be so surprised it won't. Okay. I really don't think I'm going to get anywhere, so I'm going to blow another hour and a half in here, and yeah, I've only got 4 strands of hair left at this point, for crying out loud. I can't risk it. So what I'm going to do is I'm going to call it, I'm going to put this guy aside. Wait until the owner can give me the original speaker. With the original speaker, field coil, the whole power supply come to life properly in here. We can carry on with everything at that point, and maybe that'll do it. Maybe this whole time it's just because of the technique I'm using for powering the radio. As much as I doubt that. Okay. I think that's it. So I'm going to post this video, and the next radio on the venture will be it's either an 8-track player or another tube radio. What's coming? 8-track player's coming next.